body, the nervous and endocrine systems produce a well-coordinated, generalized, non-specific response designed to ensure the survival and health of the individual and maintenance of the internal environment. We also have reviewed hormones associated with situations that pose a serious risk or physical or emotional harm to a person. In each instance, the body responds in individual ways to maintain homeostasis and with a coordinated, generalized, nonspecific response called the stress response. Increased blood levels of the hormones epinephrine, norepinephrine, and cortisol are markers that indicate that an individual is experiencing stress. Click Continue to observe stressors. The hypothalamus directs the body's stress response. The nervous system sends information about the stressful condition to the hypothalamus, which then engages both the nervous and endocrine systems in response. Click the hypothalamus to begin. The hypothalamus engages the sympathetic nervous system in a neural and endocrine response, the well-known fight or flight response, which prepares the body for immediate physical action. In the combination of direct action by the sympathetic fibers and epinephrine from the adrenal medulla, cardiac output, CO, increases, ventilation increases, blood pressure rises, and is maintained at a level adequate to drive blood to the working organs, and blood flow is redirected from the GI system and other quiescent organs to skeletal muscle and the heart. Sweating is stimulated. Epinephrine reinforces the actions of the sympathetic system, especially relaxation of the airways and dilation of blood vessels to skeletal muscle and the heart. Epinephrine directly stimulates tissues to meet increased metabolic needs. The major effects of epinephrine are stimulation of glycogenolysis in liver and skeletal muscle, gluconeogenesis in the liver, and lipolysis in adipose tissue. Glucose and fatty acids provide fuel for working organs. Glucagon reinforces the fasting metabolic state, and the active inhibition of insulin is essential to keep plasma glucose levels high. The fast-acting catecholamines initiate the stress response. They produce rapid, short-term changes because they are secreted rapidly from storage vesicles, and they act rapidly on target cells. The effects end quickly when catecholamines are removed. Click the anterior pituitary to continue. The hypothalamus stimulates release of corticotropin-releasing hormone that causes secretion of ACTH, and ultimately cortisol for a more prolonged response. Because its synthesis and release are slow, and cellular responses require transcription and translation, the effects of cortisol occur after a lag of about 30 minutes. Click the adrenal cortex to continue. Adrenal cortical hormones maintain and amplify the effects of adrenal medullary hormones. Together, the two parts of the adrenal gland act as a functional unit that produce glucose. The amino acids can also be used to repair damaged tissue. Cortisol acts on the liver to both produce glucose and store it. Fuels continue to be made available, glucose for the brain, and fatty acids for important contribution to maintaining blood pressure. Cortisol also inhibits inflammation and other aspects of the immune system, keeping it in check. Click the hypothalamic pituitary axis. Aldosterone is secreted from the adrenal cortex in response to increased angiotensin. It promotes retention of salt and water to maintain blood volume and to review what you have already learned about epinephrine and to expand your understanding of it, click an image. In the secretory activity of the adrenal medulla is rare. There are no recognized pathologies that cause hyposecretion of the catecholamines from the adrenal medulla. Because the sympathetic nervous system may replace many of the functions of the adrenal catecholamines, an individual can live without the adrenal medulla as long as the sympathetic nervous system is intact. A rare tumor called a pheochromocytoma actually found in the adrenal medulla, secretes large amounts of catecholamines and is not controlled by the sympathetic nervous system. Symptoms associated with the pheochromocytoma may be persistent or intermittent. Episodic symptoms can arise from probing the tumor, standing up or lying down, or abdominal pressure. This patient has a pheochromocytoma and has learned about cortisol, and to expand your understanding of it, click an image.
Так, ну здесь давайте дальше посмотрим. Еще есть какая-то картинка, что влияет. Вот, теперь посмотрим,
One way
что
that
есть.
scientists learn about the endocrine system is to
Вот, девочки,
observe the
переведите
symptoms of
верхнего
patients who
человека,
secrete
если
too
есть
much
который
or too
находится.
little of a particular hormone.
Аддисонная болезнь. А это
Illustrate some of the functions of cortisol. Cushing's disease, or hypercortisolism, occurs when the body is exposed to high levels of cortisol for a prolonged period. Addison's disease, or primary adrenal insufficiency, occurs when the adrenal glands produce too little cortisol and too little aldosterone. Cushing's disease is caused by tumors of the pituitary that secrete increased amounts of
с одной стороны
ACTH.
Кошинга, а с другой стороны Аддисона.
Hypercortisolism,
Кошинга у них обычно
Муж
отек.
это что?
such as
Кто муж?
glucocorticoids,
Матч. Много кортизола.
Это много.
А липа мало.
Мало.
rheumatoid arthritis,
Видите, он
other
такой
inflammatory diseases,
красивый.
suppression following organ transplant. Addison's disease is caused by